Thank you. Hello. Yes. Thank you. Yeah, so I'm Thomas Qvidahl. Hopefully this will be a fun session. I haven't really timed it, so I hope I can fit it in the 20 minutes that I have. So we'll see. This started kind of with a project for a client of ours where they wanted us to see if we could like shift left in security. So while the last speaker was talking very holistically about trusting no one in the whole ecosystem, we are talking now about specifically in the left side of your build pipeline, where you are signing your commits into the code repos. So it turns out that the SSH keys and stuff like that used in GitHub, it signs your transport, your traffic, but it doesn't really authenticate you as a user. So we'll see just quickly about that. So the mandatory me slide. So I'm a senior software engineer for Tietoevry. I work out of Trondheim, Norway. And they have graciously sponsored me to come here to this conference and have this talk. I love all things open source. Tietoevry is more a classic corporate environment where open source is just, we just take it. So I'm really working hard to make them understand the usage and the value of open source and how it's embedded in absolutely everything we do, because they don't know, not even the developers. So it's very interesting work, very hard. It's an uphill battle, but I think I'm winning. No one disagrees with me anyway, so we'll see. So this is the agenda. Just run through it really quickly. I think the Q&A will be in the hall afterwards. We'll see, we'll have a quick look at cryptography, just how it works, just not deep, just above the covers. A little bit about PGP and GPG, how they came about. Conditional Git configs, if you're not aware of that, it's a way to like segregate your configs so you can have different configs for different repos, different clients if you're in the consulting business as I am. And then signing the Git commits, which is practically the meat of the matter. Then how you can publish your keys and have other people sign your keys so you can build a web of trust around your team at least. Even if it's hard to do globally, you can build a team of trust. So also enforcing these signed commits in your repos and in your build pipelines is an important thing. And just a quick roundup about pros and cons of signed Git commits. So here we go. Symmetric and asymmetric cryptography, I guess it's known to most people as terms that you are using. But if you really get into it, it's you can talk about generally distinguish between symmetric and asymmetric. Where symmetric is where you use the same key for encryption and decryption, and asymmetric will use two different keys, where one key will decrypt whatever the other key has encrypted. So basically, or mostly the symmetric algorithms are stronger, and thus you mostly use shorter keys, while most asymmetric encryption methods are not weaker, but they demand larger keys to have the same equivalent strength. But the symmetric encryption is less computationally intensive. Keys are harder to distribute than for asymmetric keys, and that's of course a relative term. But the common denominator between these two is that the key management is the hard part, and it's the weakest link. It's where you can really mess up and where you can lose your confidence. So keeping secrets is hard, as we all know. So quickly how symmetric encryption works. You have a plain text that you want to encrypt. You use a key and an algorithm for this purpose. It's just a black box. You don't know what happens in there, but you provide the plain text and the key, and you get a ciphertext. And the recipient can use the same key and the same algorithm to decrypt the ciphertext into plain text. So far, so good. That's very general, but this is basically how it works. So a little deeper into it. So if you need to encrypt larger data sets, symmetric encryption can become too computationally intensive. So the thing you could use is you create a a random key that you use for symmetric encryption. You use that to encrypt the data, the large data set that you want to encrypt. And then you encrypt the key with the recipient's public key, which you can download from wherever, how they publish it. And then you can send the encrypted encryption key to the recipient. They are the only ones who can decrypt it, thus, because they have the private key. Thus, they can also decrypt the message that you send, possibly over another channel. It's not really important. But the distribution of the key becomes a lot easier because you can use the recipient's public key, which they can transport in the open. Okay, so I had some points here. It's like we have to, I should click them as we go through this, but let's see. There we are. It's going really fast. So how much time do I have? 14. Good, no problem. So yeah, so this is how that part works. And there's one more quick concept that we should look at. It's hashing or one-way functions, where you would where you can see that if you hash a text, a plain text, like in the first example, hello world with a capital W, you get a hash that's completely different from the second example, and it's computationally infeasible to return this value and or try to find the value, because that's how it works. It's the one-way function that works like this. So so a good system should never really like save passwords and stuff in plain text. Instead, you hash the password, you salt them and stuff like that. But we'll skip that for today. This is just a quick intro to signing, and then we have the whole example where you can make sure that the message that is meant for a particular person is also the same. The person that receives the message is then the message has not been altered in any way. So you can send it in clear text with the encrypted hash of the message, so that the recipient can verify this, and everyone else can verify that the message has not been altered, and the recipient is who you think it was. So this is what a public key looks like. My public key. Also, I've used Keybase for keeping my public key and some other stuff. It's really easy to use. It's open source, as far as I know. It's not had any major issues. So yeah, and Gunis is me. It's a game character I made once, so it just became the natural username. So you can go there and find me and the Keybase and the public key if you like. So quickly about pretty good privacy. It's a software or became a standard in the early days, like the previous speaker was talking about in the 80s and 90s, when we weren't really connected. People were still making privacy software. So PGP and the similar software, it follows the RFC, the Open PGP standard. It's RFC 4880. And this model follows a web of trust rather than the certificate models that we know from SSL TLS, X509 standard, where you have a centralized point of trust that everyone needs to sign off from, which is removed in this model. So we'll look at the web of trust a little bit later. So later than the Free Software Foundation created the GPG, it's the Gnu Privacy Guard. It also follows the same standards, and it was originally developed by Werner Koch. It's an encryption program. It's a software package that's used for signing, encrypting, decrypting, and keeping like a database of all your known keys and other people's keys that you know. You can sign and use this. So there's a link in the presentation for an article about how GPG is almost bankrupting the author. I saw also that since then he has had some funding, so it's not as bad as it sounds. But it's a good thing, because GPG is a very versatile and very useful package. So installing it's very easy. Install using your favorite package manager. We're not going to go through this. The original talk had a demo, and it was the entire thing was about an hour. Then again, I did it in 40 minutes last time, and now I have 20 minutes, so this is really getting into compression. So yeah, you can look at the algorithm, and I mean the documentation for how you set up your own GPG keys and use that stuff. But we're just going to look into now how you set up the Git config. So it's we call it conditional, that you where you have you can see that I have my, okay, where's my pointer? There it is. You can see that there, yes. So this is my home directory git config where I put in my name and my email address because I need that for all the repos that I use for all the clients. So this will be inherited into each of the other configuration files. So inside the git config, you also include, you see that you include all subdirectories of, or you include the git config from the code subdirectory where I keep all my repos. And once I have that set up, it's down into the code repository. You can find another git config, which was included in the first one. And this one includes also for all the other repos where I have my clients. So this is one client. Oh, sorry. This is one client, this is another client, a third, a fourth, and a fifth client. So these are all, they have their separate configurations because I need some different setups for each of them. So in private, I use my private email address and I override that with the config in there. And we'll look at how it's done. So also you can see the git config here now. We're one level deeper. I'm inside the client directory for Telenor. And here I just assure that the email address is the one that I use for work because they're very adamant about using the correct one. But I've also added my signing key, which I can get out from GPG. So I do the GPG command for listing keys, and I list it in a long format, and I list the key for the email address that is shown. And so I see that the thumbprint for this key is listed there, and I put that into my git config. So that tells GPG which signing key to use, and I also make sure that it signs every commit, and it just says to use the GPG program. If you have your program at another folder, you would like add the path and stuff in here, so you can possibly have multiple installations of GPG if you like. I wouldn't recommend it though. But you can keep all your keys in the one database, so that'll work fine. So listing out the git config, that's this resulting git config. Now this time I'm inside of the inside a repo inside the Telenor client, and as you can see in the end of the prompt, there is it's a main branch and it's in sync. So this time I'm actually inside a git repo. Before it was just git config files to spread out through the hierarchy. And as you can see, the resulting configuration is a product of all the different configs. So the top level one says my email address and my name. And then there are some others that are inherited from the global git config, which is outside my home directory. And if you see here, it includes all the different ones from the code folder. And then finally the setup for this particular client with the signing key. So listed out, the red git config is from my home directory. Second one is from code git config, and then from code Telenor, and together they make out the complete configuration. Then the actual signing of the git commits, you can configure your IDE, and you can configure like VS Code has a checkbox for always signing git commits. But if you just use the CLI, then you will always sign git commits as long as you're inside a repo that reads the configuration, which has a signing key, and that says to use GPG to sign it. So this is how it looks when I sign a commit. I use git log and with show signatures. Then you can see your trust. This one is actually signed by myself, and it says it's a good signature because it has ultimate trust, because of course it's signed with my key, so I trust my key 100%. If I had someone else's key there and I didn't know them, it would say, nah, this is not a good signature because we don't know who this person is. What you can do then is sign their key and build a web of trust with them so that all the commits will be good. And you could, I haven't actually done this, but I guess you could build a script that would run during build time to check that all the commits are in fact good and come from all your team, and there's nothing else been snuck in there. So by enforcing the Git commits, signed Git commits, and also something called branch protection, which is available in GitHub Enterprise. Sadly, not in the free version, but you need the enterprise stuff, I think. That you can set up that branch protection will say that, okay, if there is any Git commit that's not signed, just stop. We will not merge it. And also check the GitLab and Git also supports this. So signing, when you set it up like I've done previously, it's completely transparent. The user doesn't have to think about it. And also if you use branch protection, then if they forget to set it up, it still won't work for them. So you're safe there. It's a little bit more work because you can't just go into the GitHub UI, the web UI, and just merge your commit, because also merge your PR, because also the merge commit needs to be signed. So you need to pull that down, merge it locally, and then so you can have it signed. A little bit more work there, but it's I think it's a minor inconvenience. We didn't have anyone complain after they understood what they had to do, so it was very, very easy to do. So there we go. We have ways of signing each other's keys that can be done to build up a web of trust, to make sure that all your commits that are put into your repo, everyone knows each other and can vouch for everyone's identity. So the top photo is how you think a signing key party would look like, and the bottom one is how it actually looks. So people would meet in person and identify themselves and sign each other's keys and make sure that everything is good. I think we have to skip this now, but this is how the web of trust works. So it's direct trust and indirect trust, because I trust you and you trust another person, then I can implicitly trust the other person as well, because I know you and I think you're a good guy or girl, and yeah, so basically that's it. The internet serves up a few key servers where you can upload the keys and have their thing done. The Apache organization has a project called Calcite. They list all their team members' keys in a key file, where I presume that they are also using this to verify that all the team members that are working together are the actual people that say they are. So, of course, this it means that you have to manage the keys well. So the private keys should never leave anyone's computers, of course. And when people leave the team, they should also make sure that private keys are not leaked afterwards. And public keys that are already uploaded for part of a team, if the person leaves the team, you have to also remove the public key, of course. Signing will still work because everything that's been signed previously will still be there, but the public keys should be moved outside of the trusted core, to say that, so they won't accept any new signatures with that public key. So yeah, quickly, as I said, I checked out a little bit around GitHub, GitLab, and Git. They all support this, but GitHub Enterprise, you need that for the branch protection and that stuff. Quickly, a summary of things that we need to think about. You can use signed commits to verify where they come from, shifting left in security and building your pipeline so that it's secure from the get-go, from the start. Eliminates faked commits. It was actually easy to fake a commit that I could put in my own I can put in my coworker's name and email address in my commits, and it looked perfectly like he had done the commit. Even had his profile picture show up beside my commit. So that was kind of, yeah, I don't know, not really scary, but it was kind of, yeah, it's something to think about. This ensures that source code integrity is being maintained, and you can force it at the server. So, well, you could say that it's not user-friendly, but like any CLI tool, it has great power, but it comes with a little bit of a uphill before you can actually use it effectively. But once you do, it's good. So I'll just leave it there, and you can reach out to me on Twitter. This is the QR code. If you scan that, it's a Signal experiment. If you're a Signal user, or at least, or you should be, you can, if you scan the code, you'll enter sort of a lobby, like a group, where I can like moderate, and you can have a discussion there, of course, as well. And anyone who wants to communicate with me through Signal can do it by scanning the QR code. Thank you.